Yes, welcome back. I think the other episode I delayed a bit. So continuing with the recent episode, right? For those watching this particular episode on factorization with the first method with common factor, watch the recent video, the video just before this. Watch that one and come here. Now, so we got to a point that we have the common factors. We have 3 and 1 making the factors of 3, and then 2 and 3 making the factors of 6. So the common factor which appears here, the factors which appear here and here, we have 3 here, we have 3 here, under this 3 and under 6. So what do you do? The common one, you bring it outside the bracket. So we have 3 here. So if you have 3 there, this factor was left. This is 1. And 2, this factor was left behind. So those that were left behind, you bring them inside the what? The brackets. So hence 1 here, 1 comes here. 2 here, 2 comes down. Right. So with that point established, let's continue with onto the what? The other variable. Now we go to A. A is here, right? And A is here. Now they are common. They are common. So if they are common, you bring them outside. Hence, the method by common factor. So the common factor, bring it outside the bracket. So A is here, you bring it out. Now, we move to the next variable, which is what? X. X is here, X is not here. So if X is here, is not there, it still has to go inside the bracket. It remains inside the bracket. Now we move to the Y. Y is here, Y is not there, is no common, so you bring it down, so it remains in the bracket. Hence this one, I brought this one because for demonstration's sake. Now rewriting it again by convention, we have 3a into bracket x. 1 is imaginary when it comes to multiplication. Yes, in factorization in bracket it's imaginary, so 1 will be here, 1x, but you don't need to bring the 1x. Then plus what? 2y. Hence, the whole simplification becomes 3a into bracket x plus 2y. And you realize that you can't move on further. You can't go further. Hence, this is the final answer. Now, let's continue to the next example. It's actually in the what? In the textbook. Let's see. Now, this is it. 54 minus 81x. So let's see. So now, we have the second example. We have into bracket 54 minus 81x. The same example that I thought, right? The same example, following the same procedure, what I thought. So we have 54 minus 81x. Now, bring this constant, still tackling the constant first, 54, and then 81 first. So bring it down. The factors of 54, we have 6 and 9, right? Then for 81, we have 9 by 9, 81. Now, look at these factors, 6, 9, 9, 9. Which one is common? Which appears here under 81 and appears under 54? We have 9. Hence, the common factor goes outside the bracket. So 9, 9. Good. Now, let's move to the variables. There's no variable here. Hence, imaginary 1. You don't bring it. Because if you bring that imaginary 1, it's going to make this one 61 or 16, which is not so. So now you understand why in the initial example, I told you imaginary ones, you don't bring them when it comes to variables. So now, we move to the next term, which is 81x. Now, what is the variable here? Variable is x. Now, x only appears here. It doesn't appear under this term. Hence, it remains in the box or in the brackets. So let's rewrite them, closing up the spaces. So it becomes 9 into bracket 6 minus 9x. Correct? Let's check in the textbook if you are correct. So that is it. 54 minus 81x. The same thing. So now that we have this concept, you realize that in this on this chapter, or let's say this particular channel, our concern or our objective, our focus is on concepts, because with concepts, applications, practicals become easy, right? So still go and watch the other one, unless maybe you have idea of factorization and this one is okay for you, but you have to watch the other one. The first one, I spoke a lot. I really took my time. So with the understanding building up in this video, I was a bit faster or quicker. So that is the same idea. If I should come to this x and this one, it's the same thing that's going to apply. There's no constant here, but we have variable, we have variables. So now, if you should come here, x cubed and x, right? You bring the common, which is what, x, bring it out. Now, bear in mind, in variables, we have something that applies as what, laws of indices, right? With the exponents in multiplication being addition, right? So if you bring x squared out, right? Now it means that this one has been taken out, right? This one, this x is the same as x1, x to the power 1. X to the power 1, we don't write it, but it is there, right? So if it's x1, meaning if you should multiply this by this, we are adding the what? The 2, 1 and 2, these exponents 1 and 2. That will make it 3 here. You understand? Right. Now, there's no common factor for y. So y remain inside. Right? So when it comes to the exponentials, this is how it is done. It's a convention. So don't get confused. Just relax and do it that way. That is it. Now, if you want to apply the same thing down here, we have 100x minus 25x squared. Right? The common factor for 125 is 25. Right? It's 25. Now, with 25 being outside, we know that 25 by 4 will give 100. So hence the 4 here. Then 25 by 1 gives 25. So the 1 is here, it's imaginary. Now let's move on to the what? The variables. X is here, x is here. We bring it out. So this x is imagined to be x to the power 1, right? And then this x also is imagined to be x to the power 1. So x times x will give us the cube, right? So this is the idea. So the whole idea about this is more like the distributive, yes, multiplying whatever is outside the bracket by whatever is inside the bracket. If you want to check, after doing this, after getting this particular solution, if you want to verify, that's when you multiply this by this and then this by this to get this thing back. So if you should multiply this and later you don't get this thing back, it means that you are wrong. So if you have time and it's a written calculation work, you can do this, verify this and get it back. But if you have been doing this and you are very sure about it, you know the concept where you are very confident because we have been taught on this channel, you don't need to go back to go and check this. So with this, you are gone. So now 25x by 4 will be 100x, which is this. Now 25x by negative x will be 25x squared, because x is here, it's assumed to be exponential of 1 here, exponential of 1 here. So we are just adding them to get these two. That is it. So with the rest of the understanding and this, all the examples, you will be able to solve this. Right. If you have any other questions or it's still finding it difficult, you can let me know in the comment section and I will get back to you on that. So basically, we have covered factorization of algebraic expressions on common factors. So that